Good evening, folks. Hope I am audible to everyone. Yeah, just a minute. Okay, so let me introduce myself. Uh, I'm Govind. So have done my masters in computer science as well in PhD, and currently I'm working as a manager of data science and deep learning, and the entire scope of artificial intelligence. Emphasis Limited, Bangalore. So totally, I have around 11 to 12 years of experience. Very recently, have been joined with emphasis as a manager for handling the data science projects and all. And my Python and data science and this complete AI, I was into since 2016, which means roughly 5 years I was into this field. Right. So that's it, and have been associated with LetsUpgrade for a long time for doing mentoring such kind of programs to evolve the artificial intelligence to the young buddies who are all going to leverage in terms of this AIML. Okay, so today's completely this buzzword is interpreting, right? Oh, AI, ML, and DL. So I don't want to take much time to discuss on the fundamentals or introduction. Rather, we'll go with the specific topic, which is EDA, exploratory data analysis. Okay, so now everybody can see the something called data. Data was producing enormously in each and every field of the a globe. It may be a manufacturing, it may be a you know automobile sector, or it may be a on a finance, a medical, and everything, right? So the data are producing very enormously. So with that data, what we do, right, is there with this data, what can we do rather than just simply keeping and storing and maintaining, and what business insights we can take it out of this data. All right, so that's what it is, the large collection of data which comes from heterogeneous business area. Okay, so let me quickly give a introduction what is exactly data science, right? And how this EDA, right, exploratory data analysis can impact this data science, right? Today, what is our agenda is like, what is EDA, how it impacts the business models, which is nothing but a data science forecasting model, and when to use, why to use, and what is the business outcome out of this ADA process, and finally we could you know describe what is the pros and cons of this ADA, right? Okay, what is exactly data science? With the data, what you can compute, or what you can come up with new insights that will drive into the you know business in a right way. I mean, like, right way in the sense, any business should run in a profitable way, right? For that, how data should be utilized very effectively and efficiently. That is actually data science. When I say, when people used to say data science, what things we should, what technique or what knowledge we should possess to become as a data scientist or data analyst or anything. So we should have some, you know, basic or fundamental knowledge on statistics, and we should have the good stuff on algorithms, right? Statistics are the one which can helps us to understand the data in an appropriate way, whether that could be used into the you know productivity or not. That is the statistics. And algorithm are the one who can take our data, business data, and which can train your machines with the help of this data, and from which it has to come up with the you know meaningful insights, right? So that insights will helpful for making any decision for your business. So very crucial thing in every business is taking a decision, right? So decision making is a very vital role that makes the business in either of the way, like whether it may take into the success, or if you take any bad decisions, it may dig into the failure, right? So decision is the key by which your business drives into the real time. How do we take that decisions? For that, we can ask some questions. Do we have any statistical analysis by which can we take decisions? Do we have any systems or models or prototype that helps us to make certain decisions? Yes, of course. We have some statistical analysis model, as well as we have certain prototype, or I could say it is an algorithm, which will help the business peoples to take a decisions. All right. So this is actually data science. And data science, what is how the exploratory data analysis makes an impact. All right. So I think you could able to see the screen. There will be a left side of the slide. I kept some processing model. All right. The data are comes in various business modules. All right. So then the data goes into the where it goes. It can be taken and analyzed by the data analyst peoples. So those peoples will be using this technique, which is nothing but EDA technique, will try to understand or fine tune the data, and they'll try to capture the pattern or similarities, or any kind of relations between the data that are going to be captured. And once the pattern is captured, whether the data is good enough for our business modules or not, right? Everything is going to be decided by the data analyst, or you can say it is an ADA technique. All right. So this is the very basic steps any data scientist should undergo, without which, if any person or any data scientist will create a forecasting model, it may be either predictive or descriptive, and that model won't be a efficient one for the just a minute. I'll just increase my volume. Okay. So Of course. So EDA is the one from which we can try to understand the pattern or nature of the data. If the data scientist feels like the data are good, then the data is going to be proceeded for the next level of the process. All right. So what could be the outcome of this EDA process? This EDA won't directly impact any of the performance of your model, since it gives the better understanding of the data which you are going to used for creating any forecasting model. All right. So I have some questions. When your data is not good, then how come the prediction is going to be better one? And definitely you are not going to get the better prediction results, since your data is not good. For that, always the first thing, we have to clearly observe the goodness of data. If so, you can proceed with the next level of the process. Okay. So, and everybody today's talk AI, ML, blockchain. Somebody used to talk blockchain and big data, and somebody talks about cloud. All right. So these are the trending buzzwords people used to talk around, and but most of the peoples are only talking. They are not going to learn the new technologies which is going to be evolved in the future world. So I don't want to take much time to discuss about these buzzwords. So let's directly move on to the R part. Okay. So you can able to see the screen. This is the role of data engineer. All right. There are a lot of process involves in the data engineering, wherein which I can take only data visualization. All right. Data visualization is nothing but the EDA, exploratory data analysis. With the data visualization, we try to observe whether our data is a good form, or whether the distribution of the data follows in a appropriate way, and do we have any noises in the data, or what could be the distribution format of the data. Everything is going to be observed, understood by doing visualization. All right. So I think there will be a series of process, like starting with software engineer, big data, programming, model, statistics, data wrangling, DB, business, data engineering, and ML deployment, right? So, and this, for doing all these steps, we need the goodness, we need uh, a goodness of the data, right? To capture the goodness, we go with the data visualization. That's what this role, data engineer. And there is another set of people who are working as a data analyst. For them also, this data visualization, EDA, is a mandatory one to do the whole stuff of the process, right? So why do I keep that slide? In the sense, we should know what is the significant level of this EDA in terms of various roles in the business. So when you are working as a data analyst, you should know EDA. When you want to be work as a data engineer, you should you should know how to do EDA. So the next thing is data scientist. All right. The data scientist, who is the one who can do like anything with the data. For them also, the very very important steps or process as a data scientist to know is EDA. That's what this graph is it's taking. So this is the traditional things. Okay, so I don't want to run the slides, right? I directly take you into some real use cases, so that you can able to understand very much, right? So yeah, we'll move on to the actual use cases. Okay, so now I'm going to take a new work file. Just a minute. Okay, so first tell you all like what are the different Python packages that we need to be installed to work with the ADA process. So let me import. So NumPy and Pandas are the default packages which we need to have to work with this ADA, and matplotlib dot pyplot splt. Then so we can take cburn. So matplotlib and cburn are the data visualization Python packages. So I'll be taking these things. Okay. Just a minute. So I'll be taking another laptop because there is no power here. Let me switch on that. So I'll be taking some of the data for our analysis. Like I'm going to give the path of the file. So I just I'll be taking this file. I'll go to the properties and I'll copy the path of the file. Alright, this is the path of the file. I'll just copy it. Yeah, just a minute. And paste it. And then I'm going to select the data, diabetes. Yes. Now the data file which I'm going to take or explore here, it is mapped to data variable. So I'll just try to display. You can see here, this is the you know data which we are just exploring using the pandas, and we'll do some of the basic stuff in the data. So we'll see the information. So it will display the entire information about the data. So it has the 768 entries and the features and the data type of every features, what is the type of how many float features that you have, how many integers features you have, and what is the memory that it has. Alright, so then data dot, I'll be taking like the next thing is going to be describe. Alright, so when you do describe, you can find some of the statistics of this particular data, which is nothing but how many features, that how many records that we have, what is the mean of each and every features. STD stands for standard deviations. This is nothing but minimum value of that particular features. This 25 percentile is nothing but 25% of data belongs to this variable, and 50% of the data belongs to this category, and 75% of the data belongs to this category, and what is the max value. Alright, so these are the basic of fundamental statistical value that we need to have to come up with any sort of analysis. Alright, so mean everybody know the average of every features. The standard deviation is nothing but, I'll just try to tell you what is the standard deviations. So head is the command to display the top 5 rows. Right. Then let me take standard deviations. The standard deviations are very simple. For example, let us take age. Alright, age, let us take a age features. What is the third one is the standard deviation. Alright, the standard deviation is 11. Let's take this point age. What is the difference of each and every individual data point of age with respect to its mean value? Right, what is the mean of the age? The age mean value is going to be 33. The average age of people is 33. Right, so this is the average age. From the average age, what is the deviation that each and every feature has? Right, that's what 50 minus 33, we have some differences. This is the deviation the age instances as its mean value. Right, so 50 minus 33 will have some value 17, then 31. The next records, the next person has the deviation with the mean value is 33, so only the 2 years difference, and similarly 32 and 21. So each and every instances has its own deviations from the mean value of the particular features. That the deviations, it's very simple. The average of these differences is actually the deviations. That's what standard deviations. So how do we do the standard deviations? Let you take this 50 is a x and this is the mean value. Right, so x minus the mean is going to be denoted as x bar. Alright, x minus x bar divide by the total number of records n. If you, that is the formula, because always you don't memorize all these statistical formula. We have to logically think and map it into our mind so that you'll be understanding very easily. So 50 minus this one divided by n, right? That is the common formula for taking the for calculating the standard deviations, right? So what is the standard deviation? 11. 11 is the it's a it's a average. I can say that's what a standard deviation. I cannot say it's a standard deviation, right? So I cannot say it is a what is that, average. I should say it is a standard deviations. So the standard deviations from each and every instances of the age is deviated averagely 11 years. That is the standard deviation, right? So why do we need a standard deviations? So if I have the standard deviations, right, I can say a very good example for understanding the standard deviations, right? Standard deviation is nothing but variance, the variance in the instances of any features, right? So for example, I have a records like I have almost in this records, you can find out here how many entries, 768 entries, right? So 768 patient records. This is all 768 peoples are in the same age, for example 40 40 40, right? With this data I cannot come up with any kind of insights, since right all these age of peoples is 40, then how come how can I forecast, how can I able to give a solution for different age of peoples? This, if you have all the ages are 40, then there is no variance in the features. So then when we do not have any variance in the features, that data is a dead data. All right, so what we have to do is we need to have some significant amount of variance in the features. If so, the data is being useful, right? So as I said initially, the objective of this EDA is to understand the data nature, right? So what is the first nature of data? Your data should have the variance, all right? So if your data doesn't have any variance, it is very difficult to use the data to predict anything, all right? So that is the first point that I can give you here is the data should have variance. How do you understand the variance? By measuring the standard deviation or by looking the standard deviation of every features, all right? So you don't need to compute all these statistical values. It's very simple. The Panda is a powerful Python package which can directly, once your data is explored in the framework, the Pandas is computing all such kind of statistical values by defaultly. Whether you required or not, the Pandas will do all the stuffs for you, all right? In case if you are going to use any algorithm or any visualization method, that algorithm or method won't ask us, hey, to provide me a standard deviation, hey, to provide a mean value. It never asks us. It will directly go and take it, right? Because it's all pre-computed and kept inside the Pandas library itself. That's what when you use all these Python packages for supporting or for developing a machine learning or data science model, all the packages have been installed on top of each and every packages, which means that I can say a quick idea about it. On top of SciPy, NumPy was installed. On top of NumPy, Pandas was installed. On top of Pandas, Matplotlib and Seaborn was installed, right? So I hope you can able to map or understand these sort of integrating of the Python packages. Why? Because every packages will be directly took what it want from the packages, right? That's what. Okay. So I hope you'll have some idea about the standard deviation. Standard deviation is nothing but variance. Okay, I can give another example for variance. All right. Maybe the people who are all admitted as a cardiac problem. All right. The patient who is suffering from the cardiac problem is admitted into the ICU. Then definitely that particular patient ECG is is being monitored, right? So the ECG machine, right, is the machine as displaying the heartbeats or functionality of the cardiac, right? So in the ECG graph, right, it is also graph. It has to be always ups and downs, right? The graph should be goes up, downs, up, downs, up, downs. So if it's so, then it means that that person is live. So when that variance in his or fluctuation in his heartbeats, when it goes flat, what happens? The person is no more. That is the indications. Similarly, you can just apply that principles onto the data. So when your data doesn't have any variance or fluctuations, so it is a dead data. Nothing, you cannot come up with the data as insights. All right. So again, I'll be insisting here, we'll be just creating a little bit insights. That insights will help you to come up with, to take any decisions. That's it. So at last, decision making, this is the decision making, right? Your forecasting models help you to make certain decisions, right? For that, it is helping us. Okay. So similarly, the data should have variance. Yeah, fine. I think you'll all understood. If you follow clearly, and if you have some pre-request of pre-knowledge of this EDA, and my question is, all right, and what is the standard variance level of the data? All right. So sometimes I said there should be a variance or fluctuation in the data, but what is the limit or range of this variance or fluctuations? All right. So let us come back to the what is that heart patient ECG monitoring systems. So there are certain levels, right? There will be a neutral, and then there will be a one up and one down. Maybe let us take it as a 70 heartbeats per second. That is a let us assume that is the maximum, and the minimum, let us fix is it is going to be like in the negative light, it is going to be like 30 or something like that. So always your data, your heartbeats should be lies between minimum 30 to maximum 70 or 80. All right. If so, your system isn't good. All right. So if it goes behind 70, suppose you that particular person has the 180 as a heartbeats, then what happens? Whether it is good for the patients? No, right? Similarly, if the patient has the 20 as a heartbeat, is it good enough? No. All right. So we have a specific range wherein which your data can showcase their goodness of the nature. Similarly, in the variance also, the standard deviation has some significant range of the values. I can say like there is no standard range of variance or standard deviations in data science. So out of my experience, similar to me, every data scientist persons will decide based upon their experience with the data. I always recommend or suggest the what is that variance? It's going to be minimum we should have 15 to 20% of variance. Maximum we should have 30% of the variance in your features. Right. So let us assume that, let us keep as a boundary 15% to 30%. If your feature has the variance in this ranges, I said perfectly it will be fit for making, or it is good fit for make use of the data to convert anything. All right. So whereas that is the, I said it is the good ranges of variance. If your data has like below 15%, definitely if the patient has 20 heartbeat, definitely that is, maybe he is live, he is in serious condition. Similar to that, you can map into the data. If you have 8% variance, yeah, of course it is good variance. You have variance, but it is not good enough. So that data won't come up with a efficient model, right? That is the observation we can take it out. Okay, so I have given something about standard deviations, right? Or else I can say it is a variance. I hope you all know the fundamentals. If so, when you take the square root of the variance, that becomes as a standard deviation. It has the a lot of backend mechanisms, right? So if we talk, then it takes our time, entirely. So I have just given some idea about standard deviations, right? So next thing is, so histogram, and what you will be understanding from the histogram. So will capture density of the records with the different bin values. All right, so I'll just demonstrate with this data. So let me take the same thing. All right, data dot is this the method to generate a histogram, and I can fix the size of the histogram so that it will be so clear. So I can say 10 comma, it is the axis value, 10 is the x axis and 12 is the y axis, the figure size. Just will wait a while. Yeah, fine. So we got it, like this is the histogram. For you could able to see here, for every features there will be a one individual graph is plotted, right? Yeah, fine. So I said, like we'll capture the density of the records with the different bin values, right? Okay, so I'll make you clear or make you understand what this point says. Age. Let me explain you with one feature's age. Let you take here, like there is a bin ranges. Bin is nothing but the range of age values which the feature has. I think the minimum value for the age is going to be 21. How I'll be finding here is because next to 20 the histogram starts, and where it ends, I think 80 or 81, because it doesn't have the clear visualization, because if I do it for a one single features, it will be so clear. Okay, so so the maximum age of the person in the data that we have is 80. Let us assume that. So when you have this histogram, 20 to 25 or 30 peoples, 20 to 22 age of peoples as 300 records, which means that the people age as 21 to 25 or 30, they have their density is nothing but 300 records. 300 peoples will be there in the data with the age of 20 to 25. So, and similarly you come up with the next 25 to 30, we have around 150 records. Then 30 to 40 we have around 90 or 95. Then 40 to 60 in an average we can have 50. Then 60 to 65 we have 10 records or 20 records. When I come to 80, we don't have records, we have only 1 records. What is the understanding that we are going to take here is, when you keep this as your features, when you build any forecasting model, this histogram says this data perfectly works for the age between 20 to 30, because those people has the higher number of records. All right, So which means that when you use this data, your what is that, your algorithm make use of these age of peoples. It can capture the pattern or similarities in the age. So it will work fine for the people who falls into the 21 to 30 very effectively, right? So with this features, if you build any model, the outcome of the forecasting model, the performance is 90 percentage. The 90 percentage will work for the people who fall into 21 to 30 or 25, since they have the higher records, right? So I can get the more evidence. Whereas the same model, we got 90% of the performance accuracy, but the 90% won't be coming the people ages belongs to 80, because I do not have the samples, I do not have the populations, I do not have the evidence for forecasting or predicting the 80 age of peoples, whether they have the because this is the data for having diabetes or not, right? It's a patient data set which will be used to classify whether a patient has the diabetes or not, right? So with this age, what we understood is the data, that is the records are or good enough from age 21 to 30, and 30 to 40 we have the moderate, and 40 to 60 somewhat okay, but later to 60 to 80 we have the poor samples. So this model won't be good fit or won't be predict effectively for the age of 60 and above, right? This is the inferences we could take out of this histogram. Similarly, you can go on, you can discuss, you can observe each and every features, try to understand the what is that, the evidence of the records, right? So likewise, you can go and you can dig into each and every features to capture the density in the sense the samples, right? Population of the particular bin values. Bin in the sense this 20 to 40, because this 20 to 40 is the one bin, 40 to 60 is the another bin, and 60 to 80 is the another bin. It's a range of values. This could be dynamically decided by the Panda itself, alright? We don't need to specify the bin ranges. So how this has been decided, how this minimum is going to be decided, how the maximum age is going to be decided, in the sense the histogram is this hist function will use the statistic value, right? It will use the statistical value to decide the bin, right? Bin ranges, and then it plots the graph, all right? So because the histogram takes the min, this gives the minimum age, right? 21, you can see here for age. And max, what is the max value? Max age, you could see here is 81. So completely the hist function is being used the statistical values which can be obtained by the Panda, from which your histogram is going to be plotted. Okay, so this is the second outcome or inferences from the histogram. The third thing is, all right, so I'll be giving data dot correlations. Sorry, we don't have capital D, we have been used okay. This is the correlations, all right. I could see here as I can put into the seaborne SMS dot. Okay, so what I do is I'll try to explain what is the correlation and how this could be used to make you understand the data, all right? So this is the heat map. Okay, so here I have just displayed as a matrix of values. When you call the core function, it will display the correlation value of each and every functions, right? And heat map is nothing but the same correlation value is going to be plotted in terms of a graph. That's it. Okay, fine. So let me tell you the what is that correlation. So I'll take some graph so that I can able to display you. Okay, so yeah, fine. I hope it would be visible for everyone. Yeah. Okay, so what is correlation and how it would be helpful for us to understand the data nature, right? It will be capture or finding the relation for one feature versus another features, right? What is the relation between the features, whether it has the positive, which means that whether it has the good relations or inverse relation, or there is no relations, right? I can give a very good example for you to understand this correlations. Then we can go and make use of these things, right? Okay, so I don't want to teach you like what is the formula to find out the correlations. I'll just try to make you understand the the significant level of the correlations. Fine. Okay, so let me take an example like there is a one diabetes patient who has been advised by the doctor, if you walk more, then probably your diabetes levels are decreasing. All right, that is the first use cases. So based out of the advice of the doctor, a patient starts walking. First day he walks 2 kilometers. Let us assume that his diabetes levels are 180, right? 180. It is not at all decreasing. Second day he walks 4 kilometers. His diabetes level was what? 180. It was reduced as 176. Then next he walks 5 kilometers. It's 172. 6 kilometers he walks. Then his diabetes level was 170. So when he walks more and more, his diabetes levels are decreasing. Am I right? So what is that? Whether it has the relation or not, of course. So the patients are walking more, his diabetes levels are gradually decreasing. So it has the impact onto the data. So this is what a correlation. But let us assume that walking distance is a x and diabetes levels are y. Then if your x value are increasing, y are decreasing. All right, that is what negative impact of the correlations, right? If one features are increasing, other features are decreasing, it is the negative correlations, negatively impacted on the x and y features. That is what negative correlations. And the next example is, right, if we buy 10 products or anything, the price is something 100, and if you increasing the number of products, and obviously the price are going to be increasing, right? So if you have in x-axis as the number of products, in y-axis we have the prices. If the product purchasing or increasing, relatively the price is also going to be increased. That is what the first graph, positive correlations, right? So in these two graphs we have the red line, right? This is the 100% positive correlation, 100% negative correlation. The third one, right? So we don't have any impact. So let us take the that patient. The patient is keep on walking. Every day he is increasing the 2 kilometer distance, but there was no reduction in his diabetes level. That's what, no correlation, no impact. And similarly, so the number of products are increasing. Your first day you are taking 10 products, the price are 100. Then you are buying 20 products, the price are 100. So what is the impact in the features, right? There is no impact on the features. That's what, no correlations. Okay, so now let us come to a conclusion for this correlation. What is the benefit, or what is the observation or inferences that we are going to take and apply onto the data? All right. So here I can say you, like again, there is no standard to be defined to follow the correlations. Out of the experience, you have to decide your own boundary value of the correlation coefficient, by which you can understand by your own way whether how far this data is good enough for you or not, right? So the correlation coefficients, if you have no correlations, the correlation coefficients are 0, the correlation values are 0. If you have negative correlation, -1. Positive correlation is being represented as +1. All right. So the correlation coefficient lies between -1 to +1. All right. Okay. Which value of correlation is useful? Whether positive correlation is useful, or negative correlation is useful, or no correlation is useful. I say 100% no correlation. If you have data no correlation, then there is no point of using or building or moving to the next step of your data science model. All right. So you can simply drop that data. You can decline that model for developing into the next step. Okay. Then we have the two options, positive and negative. What could be the useful one? Positive is useful or negative is useful? Both are useful, because with respect to one feature, other features has the variance, right? That's what we have. It will be used for both the correlation, negative and positive, right? So how it will be useful? Because the patients are walking more, the diabetes are decreasing. Obviously, it's a good sign for patients, right? So I can recommend, if I have data as such, all right. So out of 1,000 patients, 600 to 700 patients or get benefited when they are walking. Then with the data, if I build anything, the suggestions for the new patients is going to be the good fit for them, right? So that's what. And even positive correlation obviously useful. Okay. So how do we estimate in terms of values? So there is another inferences that we can take it here is, if your correlation coefficient belongs to -0.22 plus 2, you can consider it as a 0. All right, you can consider it as 0. Then what is the moderate positive correlation? +3.2 and +6 or 7, that is the moderate correlations. And 0.8 plus 0.82 up to +1, if you get the correlation, this is the strong positive correlations. That is the good for model building. All right. Similarly, in the negative side, this is the range of values that we should consider for the data, how far it is good fit or not. All right. So okay, let me come to the point. You can find here, right? So I can take pregnancy versus pregnancies. So when you have the similar features correlation, that is going to be maximum 1. So all the diagonal value is going to be 1. So don't consider this one because it is self correlation, just we neglect it. Then you can see pregnancies. Let us take pregnancy. What is the correlation pregnancy with glucose? It's 0.12. What is the 1.2? You can consider 0, right? No correlation. I said -0.22 plus 0.2. We can consider it as a no correlations, maybe it has the correlation, but it doesn't have the big impact on it. Similarly, this is minus 0.07, consider as 0, 0, 0, right? This is 0.03, completely 0. Age, you can see here 0.54, which means that it has the moderate correlation. Alright, so the first feature, pregnancies, has the moderate correlation with age, that is 0.4. Then outcome 0.22. So the pregnancy features has the best correlation to these two features, not with other features. Alright, for example, if the pregnancy feature has 0 for age, close to 0 for age, as well as close to 0 for outcome, what we can do is, you don't need to keep this features for the next step of your process. Alright, why? Because the pregnancy feature doesn't have any significance of the data, but whereas here it has the moderate correlation for age features, so we cannot deny or drop these features. Alright, so if you have clearly observed or got an idea about the correlation, you can decide right away which are the features are important, which are the features are not important for, which mean important or not important. I think it is contributions, right? So what is the contribution of each and every features towards to your outcome? Alright, so if I have 0 correlation for all other features for the pregnancies, I can simply drop these features because there is no contributions for the model building. Alright, so that is the inferences that you can take from the correlations. Right, similarly you have to check all the features with all other features, then you can have an idea which are the features are useful or not useful. So the good data scientist or data analyst peoples used to have these insights to eliminate the features which are not contributing to your model. Alright, because when you keep all the features which are not at all useful, the complexity of the machine learning or data science model is increasing. So we have to lay down the complexity of the model, so that we have to eliminate which are the features are not in the not significantly good for the model. Alright, that's it, that is the thing. And finally I'll be just plotting the pair plot, because this is the correlations. Alright, I'm going to plot this in terms of a graph with a univariate graph. You can see now. Okay, so SNS dot what is that, pair plot. So data, you can see, that's it. It takes some little time to plot the graph, but here we have seen only the value, but this pair plot will display the data distribution pattern. Alright, so how it has been distributed for every feature with the other features, that's the pair plot. This is what multivariate analysis or technique. From the pair plot you can decide the significant level of the features. I mean significant is, it's very simple, whether the data is contributing or not, whether data has the good meaning or not. Alright, that's it. So it's plotting, just a minute. Yeah, I think we got a result. You can see here, this is the plotted, right? So pregnancy with the second features, the data distributions. So as like this you can find the a pair plot which is exactly quite similar to the correlation, but the correlation will gives only the coefficient value, but this will give the data distribution pattern, right? So how was your data was distributed in the mathematical space of x and y, then you can go to each and every pair of distributions, you can find the pattern of it, then you can decide whether it could be useful or not. All right, so that's it. And I can see the next one with respect to your target. If you plot the pair plot, you can exactly find out the distribution of one feature versus other features with respect to your target. So it will be give a clear idea you know to understand the distribution of your target. So just a minute. So Q is equal to, what I have done here is like I'll be calling the same pair plot but with respect to the outcome features. Alright, so based on the outcome, how was the data is distributed in the x and y graph. Alright, so it will be giving two types of colors of the data distributions. For example, here is the outcome, is the pregnancy, right? So pregnancies are colored as red, outcome are colored as another colors. So then we can able to find out what is the distribution pattern of the outcome. All right, so that will be displayed by the this graph pair plot. So be 1 second. Yeah, I think we got it. Right, you can see here. I'll just tell you, like show you what is our outcome. You can see here our outcome is 0 1. 0 means no diabetes, 1 means having diabetes. Okay, so blue are diabetes patients, 1 are non-diabetes patients. All right, so you can see here, maybe it may be the two features. I'll take this one. So in each and every data distributions we have two colors, right? One is the brown and blue. So I can easily find out the blue data points. What is the data distribution of one category and what is the data distribution of 0 category? Because in correlation it will give the overall relations, but this pair plot will give the relation for 1 as well as 0. Sometimes there won't be the good relation for 0, whereas there will be a good relation for 1. So that it is the very deep multivariate analysis wherein which you can able to understand what is the data distribution, what is the relation of the data for these two features x and y with respect to 1 as well as a 0 category. All right, so sometimes it will give a overall correlation is maybe a 0.2. All right, I said 0.2 is the no correlation, right? So you can simply ignore it, whereas 0 category is the minus 2, 1 category is going to be the plus 6. So when you do take average, you will be get plus 2. Right, in that cases actually the data distributions for the 1 as an outcome, the relations are so good. All right, so we cannot take a decision directly based out of the correlation. Correlation is the kind of rough estimation about the features. Almost it is 90% it will be works as fine, but and above the 90%, when you want to know the detailed study of your data distribution, you have to call this pair plot, wherein which you can exactly figure out the pattern of the or nature of the data. All right, so that's it. So I'll be consolidating what we have been discussed. All right, so we have been talked about the what is data science, all right, and what is exactly EDA, and what is the useful of EDA, and what is the useful. So it will be, EDA is a kind of small step which brings the which notify the nature of the data to the person who is handling, all right. And then we have been discussed uh, statistical value of the your data, that is standard distribution, standard deviations, how the standard deviation impacts to the next level of your forecasting model, and what is the significant level of the standard deviation, and how we have to select